Lesson 7, the core math. This lesson has been created for two reasons. First, to show you how to do your own probabilities. And second, to help you internalize the math. By learning the probabilities, you become an insider, not an outsider, in the knowledge of the math. The deeper your understanding of the math, the more beauty and eloquence reveal themselves in an orchestra of numbers, probabilities, percentages, fractions, odds, outs, and patterns at the tables. Be the conductor of that orchestra. When I first started my poker journey, I pulled out a statistics book from my MBA program and learned how the core math probabilities were derived. I found it so helpful that I wanted it to be part of the book and this course on mastering poker math. I hope you find it as helpful as I did. And yes, it's a bit nerdy, but math can be a lot of fun as well. I hope you enjoy the lesson. The best way to describe how to derive the probabilities is by doing a few examples.
Example 1. This example is the same as the flush draw we discussed in the rule of 4 when considering going all in after the flop. The example is being repeated for two reasons. Number 1, to provide a visual representation of the math, and second, to help you solidify your math knowledge. You want to know what the probability of hitting your flush with two cards remaining, the turn and river cards. This is when you are considering making or calling an all-in bet. First, determine the percentage of cards that won't help you on the turn. Next, determine the percentage of cards that won't help you on the river. Third, multiply those two numbers together. Finally, subtract that percentage from 100%, 1, to determine the probability of getting your flush. Let's dig deeper. The first event is the turn card. There are two cards of the same suit in your hand and two cards of the same suit on the board. That makes 4 cards of the same suit. You need one more card of the same suit to get your flush. Since there are 13 cards per suit, 13 minus 4 equals 9 cards that can help you make a flush. There are 52 cards in the deck minus 2 cards in your hand and 3 cards on the flop that equals 47. 52 minus 2 minus 3 cards remaining in the deck. 47 minus 9 equals 38 cards that won't help you make your flush. To determine the percentage that won't help you make a flush on the turn, divide 38 by 47. The next event is the river card. Now, there are 37 cards that won't help you. There are 46 cards remaining in the deck. To determine what percentage that won't help you make a flush on the river, divide 37 by 46. Next, multiply 38 divided by 47 times 37 divided by 46 and subtract that number from 1, which is 100%. This provides the probability of getting a flush when you will see both the turn and river cards. As shown in this figure, it is 35%. This second example shows the probability of getting at least one pair on the flop with 2 random cards. The math is done similar to the first example, yet there are 3 cards that must be multiplied together instead of 2. You have 2 different cards in your hand. Each individual card has 3 cards in the deck that will pair it up. 3 times 2 equals 6 cards that will help you get at least one pair. For the first card on the flop, there are 52 cards in the deck minus 2 cards in your hand, leaving 50 cards. With 50 cards remaining and 6 cards that will help you, there are 50 minus 6 equals 44 cards that won't help you. To determine the percentage that won't help you for the first card on the flop, divide 44 by 50. Next, subtract 1 from the numerator and 1 from the denominator for the second card on the flop, 43 divided by 49. Third, subtract 1 from the numerator and 1 from the denominator for the third card on the flop, 42 divided by 48. Finally, multiply 44 divided by 50 times 43 divided by 49 times 42 divided by 48 and subtract that percentage from 1, which is 100%. This provides the probability of hitting at least one pair on the flop. As shown in the figure, this is 32%. It is approximately 1 out of 3 times. This third example shows the probability of flopping a set with a pocket pair. It's always fun to do set mining. The math is done like the second example, except the probabilities are different. There are only 2 cards in the deck that will turn your pair into a set. As before, there are 52 cards in the deck minus 2 cards in your hand equals 50 cards. With 50 cards remaining and 2 that will help you, there are 50 minus 2 equals 48 cards that won't help you. To determine the percentage that won't help you for the first card on the flop, divide 48 by 50. Next, subtract 1 from the numerator and 1 from the denominator for the second card on the flop. Divide 47 by 49. Third, subtract 1 from the numerator and 1 from the denominator again for the third card on the flop. Divide 46 by 48. And finally, multiply 48 divided by 50 times 47 divided by 49 times 46 divided by 48 and subtract that from 1, or 100%, to equal 12%. This is approximately 1 out of 8 times.
And in conclusion, it's one thing to know the probabilities, it's another thing to know how they're derived. Knowing the derivations is a higher level of understanding. The math becomes more visceral and builds confidence in your math abilities as a poker player.